Let's now talk about reflections in the y-axis. Now, let's cast our mind back to when we spoke about different transformations and reflections. Remember, if you have a reflection in the x-axis, that means you have a negative in front of the function, so negative sine x. If, on the other hand, you have a reflection in the y-axis, that means that your negative is in front of the x. So that's the big difference between whether you have a reflection in the x-axis, the negative is in front of the whole function, but if you have a reflection in the y-axis, the negative is in front of the x. So hopefully this looks a bit familiar to you because we've learned about what happens when you take the sine or cos of a negative angle. So let's look over here. Remember that the sine of negative x is the same as taking the negative out the front and then just having sine of x. And if you have a cos of a negative angle, well, you just ignore the negative and just deal with cos of x. Hence, when reflected in the y-axis, the graph of y equals cos of x transforms onto itself. So in other words, it just looks exactly like y is equal to cos of x. But if the graph y equals sine of x transforms onto the graph y is equal to negative sine of x, and you'll be seeing what that looks like really soon. In fact, right now. So let's go through this example here. It says sketch y is equal to 2 sine of negative x for x is an element of 0 to 2 pi. So we've got this domain here. Okay, so what we know is that when we have sine of a negative angle, you just take that negative to the front. So it's going to be y is equal to negative 2 sine of x. And now, what is this? This is just a reflection in the x-axis. So this is the big takeaway message here. This is the big takeaway message. I'll do it in purple. This is just for sine graphs. So for sine, when you reflect in the y-axis, it's the same thing as reflecting in the x-axis. It's the same thing. And hopefully you can see that by just looking here. You're just taking that negative to the front, and now you got the negative here, and you know that when the negative's out the front, as we said over here, it's just a reflection in the x-axis. Okay, so let's continue on. We've got y, we've got x, we need to find the amplitude. The amplitude is just going to be 2. The period is going to be 2 pi over whatever your coefficient of x is. So the coefficient of x here is just 1. So it would just be 2 pi. And then also let's figure out what the scale is going to be. The scale will be 2 pi on 4, because this is the period divided by 4, so it will be pi on 2. Okay, now remember, I'm going 2 up, I'm going 2 down. This is negative sine. It's reflected in the x-axis, because remember, that's the same thing as reflecting in the y-axis for sine. So that means I'm going to go down, then up, then down. That's what it's going to look like. The period is 2 pi, so this will be 2 pi. Then, using our scale, we know that this right here will be pi on 2. Pi on 2 plus pi on 2 is pi. And then pi on 2, well, pi plus pi on 2 will be 3 pi on 2. And then 2 pi, 4 pi on 2, same thing. Perfect, so that's what it is. So the key message here is that when you are dealing with a sine graph that has been reflected in the y-axis, that's the same thing as reflecting it in the x-axis. So it just looks like that. And then over here, sketch y is equal to 4 cos of negative x. Now, you know that when you have a cos of a negative angle, it's just ignore the negative. So what can we say here to help us remind ourselves? So let's come over here and in purple again. So this is for cos this time. I'm going to say reflection in the y-axis is equal to no change in graph. So you're not going to do any reflections at all. And you can see that here. It just goes away. You're just dealing with 4 cos of x, and that's what we're going to draw here. Okay, so what is my amplitude? The amplitude will be 4. What is the period? It will be 2 pi on 1, which is just 2 pi. We will figure out what the scale is. Two pi on 4, which is pi on 2. Now we have to be careful here because we've got a funny domain. Our domain is 0 to 3 pi. Okay, so I'm going up 4, I'm going down 4. I know that one full cycle here is going to be 2 pi. And then I can also just put in my key points here. This will be pi on 2. This will be 2 pi on 2. This will be 3 pi on 2. Then I've got 2 pi, so that's 4 pi on 2. But do you see that I haven't gone far enough? I need to get to 3 pi. Now, if I do another full cycle here, that is so ugly. Let's pretend that looks good. If I do another cycle here, what would I get to? I would get to 4 pi. That's too big. So I need to get rid of half of it. I need to get to this point right here because I know that that point right there will be 3 pi. And sure enough, if I was to keep on adding my scale here, so this is 4 pi on 2, this would be 5 pi on 2, this would be 6 pi on 2, which is the same as 3 pi. And that's what I needed to get to. So your period and your domain might not always neatly line up. As you can see here, we actually had to stop the graph halfway, and that's fine, it happens. So you just need to be aware of that happening. So this right here will be 3 pi minus 4. I think everything else is nice and neatly labeled there. Perfect. So those are some key things that you need to remember about drawing graphs, especially when they are reflected in the y-axis. Hopefully you found this useful.